Assalamu alaikum warahmatullahi wabarakatuh, and hope you are all are fine by Allah's grace. Dear students, in last video we have learned about some numerical problems calculating with the formula 1 by f is equal to 1 by v minus 1 by u, which is called it as Lens formula. In this video I am going to say some basic concept behind this formula. Let us go to the class right now. See, this is convex lens and this is concave lens symbol. The center of this convex lens is called optic center. If you observe here, there is an imaginary line passing towards the center. This is called principal axis. Suppose some few light rays, that is light rays are falling towards the convex lens. Observe here, after incident on it, it gets converges at a particular point here. This ray also converges at a particular point here, or we can say these rays are focusing at a point, that is called principal focus. As all rays are converging at a particular point principal focus, that's why this lens is called it as converging lens. So convex lens can also be called it as converging lens because due to this converging property. Here this is optic center I said, and this is called principal focus. If you imagine few light rays are falling by this direction, what will happen? It will focus towards this point. Am I right? So from this lower ray, it will also focus at this point, similar like here. So this is also a principal focus for this side. So let me consider as this is f1 position and this is called f2 position. So what is the same distance here? It comes on another side, this position. This is called 2f position. Similarly here it comes as 2f position. Same distance of focal length. Let me call it as 2f1 and this is 2f2, or I can call it as center of curvature C1, center of curvature C2. So these are some of the basic points that has to be noted while drawing the ray diagrams. Let's come here. This is concave lens and imaginary line is passing here, or a ray is passing here. What happened after incident on it? It focused towards principal focus, but it gets diverges. It is not converging, it is diverging from here. That's why the concave lens is called it as diverging lens. As I said, this is f means on other side this will be also focal principal focus here, because when a light ray falls from this direction, it gets accumulate here and get diverges from this direction. So let me write f1 and f2 here. The same distance of principal focus will be here on the other side. See, this is 2f position, this is called 2f2 position, or we can call it as center of curvature 1 and this is called center of curvature 2. So let us consider some ray diagrams here. See, let us imagine an object is here, where this is optic center, this will be principal focus 1 and this is principal, that is center of curvature point C1. Similarly here f2 and this will be C2, or we can call it as 2f2 positions. When an object is placed between f and 2f position, what will be the changes? See here, this light ray will fall like this without any deviation from the optic center, but one more light ray will incident on here, and as per the rules it will be focuses towards principal focus. So what happened? An image will be formed here. So object height is little bit here, but the image size has been increased in convex lens. This has to be noted. One more, the object is like this. AB means image distance has become like this, A dash, B dash and A dash. That is, an inverted image will be always formed in the convex lens. Not only that, the images are also real one. Real means we can easily capture on the screen. Let us come to here. This is concave lens. That is, this position will be principal focus, f1 position and 2 f1 position. This is f2 and 2 f2 position, or we can call it as center of curvature 1 and center of curvature 2. Similarly, when an object is placed here between f and 2 before a concave lens, what happens? There will be no deviation from the optic center. But when you consider here, after incident on it, it gets accumulation from principal focus, then it started divergence like this. Here what we noted is the image will be formed here itself. The image will form here. Of course, the size has been decreased as a smaller one. See, object height is AB and image height is A dash B dash, but the image is not in a inverted one, it is as a virtual and erect image. What is meant by virtual? And as convex lens, the image can be captured, but in concave lens the image is a virtual one, it cannot be captured, but it will be not an inverted one like this, it will be as erect. How the object is similar to that, the image will be a similar fashion, not in an inverted position, that is called as erect image. So convex lens always produce a real and inverted image, whereas concave lens will always produce virtual and erect image. This is the nature of the image of both the lens. Here what I have given as tabular column is to identify some of the basic things while calculating the numerical value for the formula 1 by f is equal to 1 by v minus 1 by u. What is v, what is u here means, see, object distance from the optic center from O to here, this is called as object distance. This distance is object distance, that is always considered as u in both the lens. Where the image is formed is here, from the optic center to here on the right side of convex lens, this is called as image distance v. The distance between the optic center and the principal focus gives the focal length. If you understand here, object distance is from the left side always, so it is negative as per the Cartesian sign convention. But the image is formed on the right side, so the distance between the optic center and the image will give you v, that is as image distance, that is will be always positive. What about the focal length? It is also on the right side, so it will also positive in case of convex lens. If you observe here, concave lens, the object is placed on the left side from the optic center, so of course it will also negative. But the thing which you have to observe here is image is also forming on the left side for concave lens, so the image distance can be calculated from optic center to this position. So it is also in the left side from the lens, so it will also negative. Even focal length, see the distance between optic center and the principal focus gives the focal length. It is also falls on the left side, so this also comes as negative. So the thing has to be noted here is while you are calculating focal length or image distance or object distance with the help of this lens formula, you have to keep in mind that object distance is negative for both concave lens as well as convex lens. U is always negative, but V and F is always positive for convex lens because the image and the focal length comes on the right side of the lens, whereas for concave lens all are falling on the left side itself. Object distance, image distance, then focal length, everything comes on the left side, so all the values comes as a negative one. So hope you understood. So dear students, let us know something more than the formula. Here magnification is nothing but zooming, as I said, a zooming power. In nowadays we are using 4x 6x cameras. How it zooms? It has a relation with image distance divided by object distance. Image distance can be represented by v and object distance can be represented as u. So m can be calculated, that magnification can be calculated by this relation, that is m is equal to v by u will give the magnification. So v by u will give you the magnification of the lens. Magnification of the lens. So what is the use for this magnification? Simple, height of the image can be calculated. For example, if you take here, see AB is the object height. It will be considered as H0. But the image height has been an inverted one in the case of convex lens and it has been increased here. So what will be its height? It can be calculated with magnification formula. How? See, m can also be written as hi by h0, where hi is the image height. It can be calculated, this hi can be calculated by multiplication of magnification with the object's height, where h0 is the object's height. So these are the basic concepts that we learned in previous class. Hope you understand. Dear student, power of the lens is a very important concept, because if you consult with a friend who is wearing spectacle, he will say my value is minus 0.5. Somebody will say my value is 0.1 or 1.2. D refers as diopter. It is the unit of power. So what is power? How it can be calculated? Power is the reciprocal of focal length. If you know the focal length, then you can easily calculate the power of the lens. So power of the lens differs for concave and convex lens. See, for concave lens it is represented as minus 1 by f. For convex lens it is represented as plus 1 by f. So this power of lens is very much useful in making the spectacles to have a clear vision. See, power is represented by a letter called, or its unit is called as a diopter. It is represented by a letter called D. Students, next important concept is lens maker's formula. That is, after getting the prescription from the doctor, we go for optical center to make our lens. How they are using and what they are doing means, they are using a formula called lens maker's formula. How they are preparing it, let me give an example here, then I will explain you. See here, this is our eye. Here the retina is, this is the position where the image has to be formed. But this person, if he got a myopia patient, that is, he can see the nearby objects clearly, short-sightedness, but he can't see the long distance. That case is called myopia. What is the reason behind this? Means the image is forming before the retina. If it is actually forming here, means he has no problem at all. His vision is clear, but the image is forming before the retina. That is the problem. So this distance is, let us consider as x. But the image has to fall on the retina. That is, some distance of y has to be adjusted here. That is, the focal length has to be adjusted. That's why after getting replacement with a concave lens, the image is forming from here to here. See here, the image has been now formed. So the focal length has been calculated by using proper concave lens for the myopia patient. That's why the lens makers are using a formula f is equal to xy divided by x minus y for concave lens. That is, for myopia patient they are using concave lens and the focal length has been calculated by x into y divided by x minus y has to be noted here. What about for hypermetropia, that is for long-sightedness? See here, to them they can easily see the distance object properly, but they can't see the nearby objects because the image is forming at a distance d. Let us consider here it is beyond the retina. So this has to be brought to the actual vision, that is distant vision, that is called D. That is D means this is called distant vision. Human eye can see the object without any problem. That is, it is 25 centimeters the minimum distance, or we can call it as 0.25 meter is the distant vision. That is, the human can see the nearby as well as farther image without any difficulty. That is given as D value. So this D value is very important in calculating the focal length for hypermetropia patient with the help of formula F is equal to D into D divided by D minus D. So here D is the minimum distance where the image is forming beyond the retina. So this D is beyond the retina, the image is forming the distance. This distance gives. So actually we have to correct it up to distant vision D. So the formula for focal length calculation is D into D divided by D minus D. For hypermetropia patient, they are using convex lens. So hope this two formula is very much important and you have understood how it comes. This formula is very much useful in calculating the numerical problems, which we are going to see in the next video. Thank you for watching.